Zdeb, I'm going to be proving proof 1. So we need to prove that ABC, B is a kite, and here's the image of the shape. And we were given that BC is congruent to CD, as well as AC bisects angle BCD, and this was given to us. So we know that BC is congruent to CD, as well as our AC bisects angle BCD. So we know from the definition of bisect that this angle is going to be split in half, so that means angle 1 and angle 2 are going to be congruent. We then know that DB is a diagonal of the quadrilateral ABCD, and we know that E is the intersection point. We know this because the definition of these, so it's because the definition of diagonal, as well as the definition of intersection point. We then know that EC is congruent to EC due to the reflexive property. And since we have proved that DC and BC are congruent because that was given, and we have proven that EC is congruent to EC, we know that these two triangles are congruent because of hypotenuse leg. And so then we know that BE would be congruent to DE because corresponding parts of congruent triangles are congruent. So we know that BE is congruent to DE. And so then we know that AC bisects BD because since BD, BE, and DE are congruent, we know that the definition of bisect, it's going to be splitting that line in half. And so since AC splits BD in half, because those are congruent, so we know they have to be the same, so that we know that they're both 1/2. So then we know that AC bisects because the definition of bisect. So we then know that this is a four-sided shape, and we know it's a flat shape as well with straight sides because we have AB, which is one side, BC, which is one side, CD, which is one side, and DA, which is one side. So we have AB, which is one side, BC, CD, and DA. So we have that it's four sides. So we then know that AC is going to be congruent to AC because of the reflexive property. Because anything that is equal to itself. And so now we can prove that BCA is congruent to DCA because we have that CA is equal, and we also have that BC and DC are equal, as well as these two angles are congruent. So we can say that because of side angle side. And so we then know that AB and AD would be congruent because corresponding parts of congruent triangles are congruent. And so now that we've proved that it's a four-sided shape, and we know that it has two pairs of sides because each pair is made of two adjacent sides that are equal in length. So we know that we have this pair and this pair, as well as this pair and this pair. And we proved that AB is congruent to AD, which would be one pair, and then BC is congruent to DC, which was one pair as well. So we know two pairs that are congruent.
Do you guys know what this given is?
So the diagonals. So as we said, each pair is made of two adjacent sides that are equal in length, and we know that it has two pairs of sides. So we have AB is congruent to AD, as I said before, as well as BC is congruent to AD. Sorry, it'd be DC, not AD. So we have our two pairs there. And then we also can prove that angle ABC is congruent to angle CDC. So this angle and this angle are congruent because we have been able to prove that those two triangles are congruent. So we know that the corresponding parts of congruent triangles are congruent. So, and so now we can tell that BEC is congruent to CED, and these would be, because those are both right triangles as well, and they would also form a linear pair and would be congruent. So we know that because of definition of right triangle. And we know that they form a linear pair. So then we also know that AEB would be 90 degrees and AED would be 90 degrees because they also add up to 180 degrees. Because we already know that those two would be equal to 180 degrees. And we also know since these two form a linear pair and these two form a linear pair, we know that we have two linear pairs, so they would also be equal. And so then we know that ABCD is a kite because the definition of a kite. Because we had proved that diagonals met at a right angle because angle E here, or at the point E, all of these four angles would be 90 degrees. And then we also proved that AC bisects BD. And we also proved that the angles are equal where the pairs meet. So these would all be equal because they're all 90 degrees. And then we said they have the two pairs of sides, and they're adjacent and they're equal. So BC and DC are equal, as well as AB and AD. And then we also proved that it has four sides. Thank you.
Hi, this is Celeste, and I am doing 3 of quadrilateral proofs. So what I've done, I have written down what it had given to me. So it says, given that PR and QS are diagonals of quadrilateral PQRS and intersect at point T, PS is congruent to QT and ST is congruent to RT. So what we have to prove is that triangle PQT is similar to triangle RST. So I'm going to start with what they've given to me. So I'm going to write PS is congruent to QT and ST is congruent to RT. And those are both given. So next thing that I'm going to do is do angle PTQ is congruent to angle RST, and that is going to be because of vertical angle theorem. And then I'm going to do ST over PT is congruent to TR over TQ, and that is through division property of equality. So that gives us that triangle PQT is similar to triangle RST through side, angle, side.
Pearson, and this is the proof I'm doing. I have to prove that line BM is congruent to line MA. So to start off, we have to write out our givens. So we're given that ABCD is a rectangle, and the reason would be given. And then our second given is that M is the midpoint of CA. And the reason would be given. And then after the givens, we can determine that line CA is a diagonal because of the definition of a diagonal. And next we can determine that line MA is 1/2 of line CA because, as stated in our givens, M is the midpoint of line CA, and the definition of midpoint would prove that. And next we can prove that line BM is 1/2 of a diagonal because of the definition of diagonal and the property of a rectangle. So we can prove that it's a diagonal because line BD connects at the opposite corners, and then the definition of a rectangle has the property of a rectangle that diagonals bisect, and that M is the midpoint. So we know that line BM is 1/2 of line BD. And then we can prove that line BM is equal to line MA because the property of a rectangle that diagonals are congruent and they're equivalent fractions. So what I mean by that is the property of a rectangle that diagonals are congruent means that line BD would be equal to line CA, and that they're equivalent fractions because each are 1/2 of their whole diagonal. So line BM, this part, is 1/2 of this whole line, and line MA is 1/2 of this whole line here. So since they're both 1/2, 1/2 is equal to 1/2, so then we can determine that line BMA. From property of a rectangle. And equivalent fractions. And that's it.
Okay, so I'm proving that EFGH is a rhombus, and it's already given me these points as E is a midpoint of BA, F is a midpoint of BC, H is a midpoint of AB, and G is a midpoint of CD. So first I saw that BC is similar to AD because definition of a trapezoid. And AB is congruent to CD, and that's also a definition of a trapezoid. And then, so from there, because these two lines are similar, the midpoints will be at the same spot. So HE is equal to HG. Because they're the same distance. Because of definition of a trapezoid. And then EF is equals, or is the same as FG. And it's the same thing. Only because H and F are, since these two lines are similar, the midpoints will be at the same spot, so it's equal distances. And then, since these are all equal, FE is also equal, so FE is equal to EH, and GH is equal to FG. This is the definition of a trapezoid since they're both at midpoints. And then, because they're all equal sides, it must be a rhombus. So H, G, F, E is a rhombus. These are the definition of a rhombus.